The last thing of theory portion from your consolidation chapter, that is consolidation of undisturbed specimen. Okay, consolidation of undisturbed specimen. Some terms are very important under consolidation of undisturbed specimen. Like these are important for GATE exam also. Pre-consolidate, pre-consolidate consolidation, pre-consolidation or pre-consolidate or over-consolidate, same thing. Pre-consolidate, uh, over-consolidate, over-consolidated or pre-compression, same thing. Pre-compression, compression. Actually, pre-consolidate, over-consolidate or pre-compression or sorry, then normally consolidated, and third is under consolidated. These are the actually condition of soil in consolidation perspective view. If we define any soil, which type of soil in consolidation perspective, so we can classify based on these three categories. Maybe soil is pre-consolidated, maybe normally consolidated, maybe under consolidated. Okay, pre-consolidated is the very common type, and if we go through the definition, soil deposits may be divided into three classes as regards to the consolidation history: pre-consolidate, normally consolidate, and under consolidate. Generally, a clay is said to be pre-compressed or pre-consolidated or over-consolidated. Okay, so clay type soil is normally pre-consolidated or over-consolidated or pre-compression, whatever you can say. Clay is the such type of soil. Acha. Another thing, if clay, if it has ever been subjected to a pressure in excess of its present overburden pressure, normally clay already clay already observed a experience of maximum load in his career or in his tenure. Clay, such type of soil actually which already has been experienced with maximum environment load. Okay, maximum overburden pressure clay experienced. So clay normally such type of soil which already taken load lots of load in its tenure. So that's for we can say clay is a pre-consolidated soil, normally pre-consolidated soil. The temporary overburden pressure to which a soil has been subjected and under which it got consolidated is known as pre-consolidation pressure. Again, the temporary overburden pressure to which a soil has been subjected and under which it got consolidated is known as pre-consolidation pressure. Okay, so a soil may have been a soil may have been pre-consolidated or uh, a soil may have been pre-consolidated during the geologic past by the weight of an ice sheet or glacier which has melted away or by other geologic overburden and structural load which no longer exists now. So such a load which already was applied but does no longer exist on the soil, that type of situation is called pre-consolidated condition of the soil. Like clay, normally clay faces such type of condition. A normally consolidated soil is one which has never been subjected to an effective pressure greater than existing overburden pressure. Normally consolidated is one which has never been subject to an effective pressure greater than the existing overburden pressure and which is also completely consolidated by the existing overburden pressure. So actually normally consolidated soil is which soil already taking maximum load in its tenure, already taking maximum load. Earlier the soil has taken lower than the its present load, but at the present situation, if soil is taking its maximum load, that kind of situation is called the normally consolidated condition. Pre-consolidated is already taken lots of load, already its tenure, the soil has been taken lots of load, but at the present situation the load is not there. But in normally consolidated condition, at present condition, soil is taking maximum load, but in its tenure in earlier stage, the soil has not taken lots of load or the greater load than present load. Okay, this is the difference between pre-consolidated pressure and normally consolidated pressure condition of or consolidation prospective conditions of the soil. Next is a soil which is not fully consolidated under the existing overburden pressure is called the under consolidated soil. So under processing, say under processing, it is getting some load in at its present situation, but the soil is not fully consolidated, it is premature. Soil is under under such a state where the soil is getting consolidation pressure or in a process of consolidation, but these two processes already consolidated. This is already taken load, this condition already taking load which is maximum in its tenure, and this condition already taking load but not consolidated. Some consolidation portion, some settlement is remains left for its soil mass in its soil mass. So this is the difference between pre-consolidated, normally consolidated, under consolidated. Are you getting my voice? Are you getting my voice?
Yes, sir.
Yeah, okay. Actually, lots of phone is. Yes. Okay. So mainly important is pre-consolidated. Normally, pre-consolidated is very important, and one graph is there to present this kind of situation pre-consolidated. Normally, as I said, this is important to us. This pre-consolidation we can define by this graph or we can present by this graph. Already you have yeah, the book. Which book? No. BNS Murthy. BNS Murthy. I think you have BNS Murthy. Okay. If you see in BNS Murthy, we are getting this picture.
Yes, sir.
So this is the actually I have taken from VNS Murthy. Also BC Purnia, this condition is available. These things are available, but I have taken from your VNS Murthy. VNS Murthy, one of the good book. You can follow this book also. Not always the BC Purnia is important. VNS Murthy can you follow. You can follow. So in this figure, you can see this is actually E log P curve. Very important. One of the important question for soil mechanics, for foundation engineering, for soil mechanics 1, soil mechanics 2, whatever. E log P curve. E log P curve is very important for theoretical question, for practical question, whatever. E log P curve. E log P curve क्या है? What is E log P curve? Y axis is representing void ratio, x-axis representing the pressure. Okay, this is the x and y-axis. Y-axis is void ratio, x-axis is pressure, but y-axis is your log scale. Okay, log scale. So same as this is the semi-log, actually semi-log plot. Semi-log curve is drawn in between void ratio and log P, or pressure, between pressure. As mentioned every book, common thing, that is that is, if the point B, this point B, also the name of this graph is the Casagrande method actually. But Casagrande method is not important. Important is E log P curve. You may be asked E log P curve. What is E log P curve? Okay, E log P curve nothing but E is the void ratio in y-axis, P is the pressure in the x-axis, and this is the plot. One curve is there, and from this curve we can find out the pre-consolidated pressure point of the on this curve. Pre-consolidated pressure point, that is important. From this curve we can find out the pre-consolidated pressure point. This is important. So common thing, in every book it is written that the B point, this B point of maximum curvature or minimum radius is selected, and a horizontal line, you can see one dotted horizontal line is there. Okay, B, from B gradually going in the right direction, that is one horizontal line, dotted line. This horizontal line we have to draw. Okay, when this curve is available to us, E versus pressure, void ratio versus pressure curve is available to us, where it is from where we can get this curve, from the consolidation or odometer test or consolidation test in lab. From the lab we can get this curve. Okay, void ratio versus pressure curve. When this curve is available, you have to choose one point, that is B point. This B point actually is indicating the maximum curvature or minimum radius. After that, you have to draw one straight line from the B in the right direction. After drawn this line, a tangent. Okay, a tangent. Which is the tangent? This is the one tangent. This tangent. I'm talking about this tangent. This dotted tangent. Already this straight line has drawn. Now you have to draw this tangent. This tangent. Okay. So a tangent is drawn to the curve, and now you have to bisect this angle. This angle. Which angle is just formed? This straight line, between this straight line and this tangent, the angle which is formed between this straight line and this tangent, you have to bisect this angle with by again a dotted line or a one line. Now you are getting two angles, that is alpha is the value of each angle. Alpha is the angle value. The straight portion of the virgin curve is extended back to meet the bisector. Okay, this is the straight portion of the our actual curve, which we have got from our laboratory test, E versus log P. This is actual curve, and this portion is straight portion. Okay, and if we extended back to meet the bisector, this is the bisector line, just we have bisected this angle between straight and this tangent. If we extended our this from this curve, straight portion of the curve back to meet the bisector, we will get the pre-consolidation pressure. Okay, This is actually pre-consolidation pressure. This is actually pre-consolidation pressure, and this whole story is about the E log P curve. The purpose of the E log P curve to find out this PC value. This may come in theory as well as in GATE exam also. This question may come. Okay, some short question may come. What is E log P curve, and what are the elements of E log P curve, like that. So in one of the important thing, this is one of the important thing. Next, straight we have to go to the our next numerical questions. Okay, so do you have the copy, pen and paper? Hello.
Yes, sir.
Okay, please write this question. Please write this question. The loading period for a new building extended from July 1982. In July 1985, the average measured settlement was found to be 6.78 centimeter. If it is known that ultimate settlement will be about 25 centimeter, estimate the settlement in July 1991. Assume double drainage to occur. The loading period for a new building extended from July 1980 to July 1982. In July 1985, the average measured settlement was found to be 6.78 centimeter. If it is known that ultimate settlement will be about 25 centimeter, estimate the settlement in July 1991. Okay. If we go to the solution, you can see the since the loading period was between July 1980 to July 1982, the datum will be the middle of the period, that is July 1981. All the computations will be done with reference to this data. Okay, so this difference is 2 years, 1982. Okay, 19802, 1982. So at that situation, 2 years difference actually. The datum will be the middle of the period, that is July 1981. Okay, middle period should be taken. All the computation will be done with reference to this datum. Hence, the settlement of 8.78 centimeter observed in July 1985. As per question, in July 1985, after 3 years, 1982 to 1985, after 3 years, the average measured settlement was found to be 6.78 centimeter. So, hence the settlement of 8.78. My God, the wrong value is given. It should be 8.78, not 6.78. 8.78. Achha. So hence the settlement of 8.78 observed in July 1985 will be after 4 years, that is July 1985 minus July from the reference or datum level July 1981. The settlement 25 centimeter after a period of 1991 minus 1981. 1991 is the we got the final settlement. At estimate the settlement in 1991, that is final settlement actually 25 centimeter. So our datum is 1981 and the final settlement date is 1991. 1991 minus 1981, that is 10 years. Okay, 10 years has been taken. 10 years have been taken for the final settlement, and final settlement value is 25 centimeter. Thus, when time t1 was to 4 years, settlement is 8.78 centimeter, this value, and when time t2 is 10 years, settlement we don't know, that is required to find out this value, rho 2. Okay, this is the actual requirement, rho 2. We have the data, this kind of data we have available. Now we have to find out the actual settlement. Okay, now next, degree of settlement. Degree of settlement, which formula? Degree of settlement we can get from this formula. This formula, this is formula for degree of consolidation. Rho by rho wave, average settlement by final settlement into 100, and this formula for time factor, TB equals to CB T by D square. So these two formulas are required for this numerical. Degree of settlement after 4 years, because when time 4 years, settlement is available to us from question. Now, so now required to find out the degree of settlement, or say U1 after T1 or 4 years. 6.78 by 25. Again he first here written 6.78, then 8.78, again 8.78, again 6.78. Just wait, I check. 6.6, actually value is 6.78. This is wrong. This is wrong. Question is okay. This value is okay. This 8.78 is wrong. It should be 6.78. So degree of settlement after 4 years, 6.78 by 25. This formula is used to find out this value. This formula is used. 6.78 by 25 into 100, degree of consolidation or settlement. Okay, next, degree of settlement U2 or U2 after T2 or 10 years. So rho 2 already we have considered this settlement. The time T2 10 years, settlement is rho 2. So degree of settlement U2 after T2 or 10 years, rho 2 by 25. Okay, same formula, rho by rho f into 100. So 0.04 rho 2. Assuming the degree of settlement to be less than 60% in both the cases. Why we are assuming that? Because we have two options for calculating such kind of problem. When u is less than 60%, then time factor formula is time factor equals to pi by 4 into u percent by 100 square. Okay, this is one formula, and another formula, if u greater than 60%, then we should use this formula. But here no degree of consolidation has been mentioned, so that's why we have taken our preferable value, which is very easy to calculate or which can be taken for calculation. So for that cases we have taken, assuming the degree of settlement to be less than 60% in both the cases, we have from earlier equation, TB equals to pi by 4 into u by 100 square. This formula applicable to find out time factor for degree of consolidation is less than 60. Then we can use this formula, TB equals to pi by 4 into u by 100 whole square, or u equals to 1.12 84 root over TV. And when u is expressed as a fraction, when u is expressed as a fraction, okay, hence row 1, okay, row 1 settlement for 4 years, row 2 settlement for 10 years. Row 1 by row 2, u1 is the degree of consolidation or settlement for this 4-year case, and u2 the degree of settlement for this 10 years case. So row 1 by row 2 equals to u1 by u2 equals to root over tv1 by tv2, that is time factor tv1 and time factor tv2, time factor for 4 years, time factor for 10 years, and root over t1 by t2, also the time for 4-year case or time 10 years case. Since TV formula we are getting from this, this is the TV formula, TV equals to CVT by d square, and now we can apply here TV equals to CVT by d square, where CV by d square is a constant. All the cases our coefficient of consolidation is constant, CV is constant, because we are handling with same soil, okay, so coefficient is almost same. And D is the drainage condition. Drainage condition already mentioned in the question. Assume double drainage to occur. So all the cases double drainage is there. So D also constant. So we can write CV by D square is a constant. That's why now replace this row 1. Row 1 value is 6.78 from the question, and row 2 is unknown to us, equals to root over time is 4 for T1, 10 is for T2, and now finally the row 2 value is available to us, 10.72 centimeter. Okay, this is the one method through which we can calculate if we have the time, the loading period for a new building extended from July 1980 to July 1982. That's kind of data is available to us. We can calculate the settlement of the soil sample beneath the building. So since the value UT is less than 60%, okay, less than 60%, the above use of approximate equation is valid. Normally this kind of method we can apply everywhere, no problem. You can consider the you can assume the degree of settlement or degree of consolidation to be less than 60% in everywhere, no problem. Just solution is the matter. How could you solve this problem? Okay, you can send me back in my mail after solving this problem. I will be happy. Now next problem. This is one of the another biggest.
It's one some network issue, so I could not able to send that solution, sir.
Okay, those have network issue, no problem. A network issue always here. Just you have just give me the message, sir. Network issue. Just okay. Anytime you you
Okay.
should. Anyone. Okay, just uh, just we can go to the next problem. A building column has a footing area of 2 meter into 3 meter and transmits a pressure increment of 150 kilonewton per meter cube at its base embedded 1.6 meter below ground level as shown in figure. Assuming a pressure distribution of 2 vertical to 1 horizontal, determine the consolidation settlement at the middle of clay layer. Consider the pressure variation across the thickness of clay layer, also given the following. So question पहले समझ लेते हैं. So first understanding of the question is important. A building column, this is a building column, has a footing area of 2 meter into 3 meter. This is the footing of the building. This is the footing of the building. Okay, this is the footing of the building. a building column of a footing area of 2 meter into 3 meter. This is footing, 2 meter, which is showing from the front side, and 3 meter, which is not visible to us in the vertical direction. Okay, this is the two dimensional figure. So the 3 meter is not visible to us. This is only 2 meter. We can see only 2 meter. This 3 meter is not visible in this figure. So but this is the square footing and the or rectangular footing. Rectangular footing. So the area is 2 into 3 and transmit a pressure increment of 150 kilonewton per meter square. Okay, so pressure is transmitting 150 kilonewton per meter square. Just do it. At its base embedded 1.6 meter below ground level. So this is the ground level. This is ground level. Okay, this is the ground level, and the base of the footing is below 1.6 meter from the ground level. 1.6 meter from the ground level. Assuming a pressure distribution of 2 vertical, 1 horizontal. Okay, this is the pressure distribution diagram. The load from the footing is distributed to the soil, the ground soil, underground soil. Okay, this load of this column footing is coming direct to the underground or the soil below this footing, distributing the load. And this load distribution figure, at this load distribution figure you can see the slope is 2 vertical to 1 horizontal. Okay, determine the consolidation settlement at the middle of clay layer. At the middle of clay layer, where this is the middle of clay layer. Actually this position is the middle of clay layer. Okay, first layer is sand, second layer is also sand. Okay, no, two soils are there. One is sand layer, another is clay layer, and in between sand layer there is water table. Okay, water table is present. So sand is there, clay is there. Now you have to find the settlement at the middle of clay layer. Settlement at middle of the clay layer. This is the actual question. Consider the pressure variation across the thickness of clay layer also. Given the following: for sand, unit weight is 16.5 kN per meter cube and saturated unit weight is 18.5 kN per meter cube. For clay, saturated unit weight is 16 kN per meter cube. Initial void ratio is 0.95. Compression index CC is 0.26. These values are available. Next is suppose solution. If we go to the solution, so from the solution, initial pressure at the center of the clay layer is intention to find out. So initial pressure we can find out sigma 0 dash, that means effective pressure, sigma 0 dash equals to 2.6. What is 2.6? 2.6 into 16.5. 16.5 is the your unit weight, and 2.6 is the your depth. From where this depth has been taken? This depth has been taken from this position. 1.6 plus 1. Above water table, the load of the soil, the overburden pressure of the soil or self weight of the soil is 1.6 plus 1, that is 2.6 into 16.5 is the unit weight of the sand, plus 1 is the this depth, wait, this depth, 1 is the this depth. So 1 into 18.5 minus 9.81. Okay, 1 is the unit weight of 1 is the height, and 18.5 is the unit saturated unit weight. So saturated unit weight minus the 9.81, the unit weight of water, in which unit? Kilonewton per meter cube. So saturated unit weight minus saturated unit weight minus unit weight of water, that is submerged unit weight. Submerged unit weight into height of this submerged depth, that is 1, plus again 1 into 16 minus 9.81. 16, that is for clay layer 16 minus 9.81, because our target point is middle of the clay, so we have taken one depth, this one. So 1 into 16 minus 9.81. So total initial pressure at the center of clay is 57.78 kilonewton per meter square. Okay, this is the first part. Next part, pressure increase at the top, middle and bottom of clay layer. Pressure increase at the top, middle and bottom of clay layer. The second question, consider the pressure, assuming the pressure, determine the concentration settlement at the middle clay layer. Consider the pressure variation across the thickness of clay layer also given following. So pressure increase at the top, middle and bottom of clay layer is sigma, delta sigma T top, T for top equals to 150. 150 is the pressure increment, transmits a pressure increment. So this is the pressure increment from the footing, that is 150 into 2 into 3. 2 into 3 is the area of the footing, 2 into 3. This is the actual load by 2 plus 2. 2 plus 2 means, because this slope is 2:1. 1 is vertical, 2 is horizontal. So our this is the top portion of the clay. So at this layer 2 plus 2 should be the horizontal distance. 2 is the width of the footing, and another 2 is coming for this load distribution. Okay, if we draw a straight line from this point, so extended length should be 1 from the left side, 1 from the right side. So 2 plus 2 is the width at that position. At that position, width of this distributed length or distributed load is 2.2 plus into 3 plus 2 in the other direction, in the vertical direction, the value should be, because our footing is rectangular, so width, if 2 is the width, 3 is the length, so 3 plus 2 for this distribution of load or this slope. So this 2 plus 2 into 3 plus 2, this is the area of that level, top position of the clay layer. The area is 2 plus 2 into 3 plus 2, and load is 150 into 2 into 3, which load is coming from footing. So therefore the top position stress is 45 kilonewton per meter square. That's why same way we can find out the stress at middle position, 2 plus 3 plus into 3 plus 3. The load is same, just area is changing. Okay, at the bottom level also the area has changed, 2 plus 4 into 3 plus 4, 2 plus 4. At that level the 2 is actual, the width of the footing is 2, and another 4 for extended portion for this load distribution. And average pressure is found using Simpson's rule as under. Using Simpson's rule, we can find out the average pressure of on the clay layer. So delta sigma equals to 1 by 6 into sigma delta sigma T, incremental pressure at top level, plus 4 into incremental pressure at middle level, plus delta into incremental pressure at bottom level. So finally the incremental pressure is 31.07 kilonewton per meter square. This is slightly greater than sigma m, incremental pressure at middle position. Incremental pressure at middle position. This value 30 value. So here it is written, this is slightly greater than sigma delta sigma m, incremental pressure at middle portion. Now finally final settlement. Final settlement formula is this. Final settlement rho f equals to Cc compression index by 1 plus E0, 1 plus void ratio. H is the height of the specimen. Log 10 base sigma 0 is the initial pressure. Delta sigma is the incremental pressure by again sigma 0 dash equals to Cc already given in the question. Cc value is 0.26, and Cc only possible for only clay, not sand. Only that's why Cc value is given only for clay. Compression index is only possible for clay soil. So Cc value is from the question, that is 0.26. 1 plus E0 initial void ratio is 0.95, also given in the question, into 2. 2 is the height. 2 is the height of clay. Okay, 2 is the height of clay layer. The height of clay layer is 2, that's why H has taken 2. So 2 into log 10 base 57.78. 57.78 is the initial pressure. Also initial pressure is available from this equation, 57.78. Now plus 31.07. 31.07 is the incremental pressure in the clay layer. We have calculated from incremental pressure at top, incremental pressure at middle, incremental pressure at bottom. The total from Simpson's rule, using Simpson's rule, this value is available to us, that is 31.07, and divided by again initial pressure or initial stress, that is 57.78. Finally the settlement is 0.0498 meter or 49.8 meter. The answer of this question, which question? The answer of the question, that is the determine the consolidation settlement at the middle of clay layer. So the consolidation pressure at the middle of the clay layer is 49.8 mm. This is one of the important type of question, normally practical as well as any any practical problem as well as consolidation related consultancies. This type of situation can be handled by you anytime after completing the engineering. So this is one of the important practical related question. So I could stop today.
Yes, sir.
Wait, I'm taking the just wait, I'm taking attendance. You can send me this two solution to me after solving. You can send me It's up to you. It's your choice. You can send me. If you send me, I will be happy, and you will get privilege from me. Okay. Thank you.
So to
Thank you.
send this question,
These two questions, just these two medical. Okay. Uh, Screenshot, please take in screenshot. I think it's better. Take in screenshot. I'm sending, but I will not send these questions. Maybe I'll send question but not solution. You can take the screenshot.
yes, sir.
Take screenshot. It is better. Number one, number two. Then then this one. Okay, these are the actual solutions.
Page number 97 you missed, sir.
Roll number. Yes.